for you after the session is over. We'll be posting it to our website. So if for any reason you need to jump off early, you'll be able to reference this. It'll be posted to our website within the next couple of days. So we're happy that you're all able to join us tonight to learn a little bit more about mechanical engineering. Just real quickly, these are our panelists and participants tonight. So my name is Colleen Bailey. I'm the Director of Enrollment Management for the College of Engineering. We're also lucky enough to be joined tonight by Dr. Dave Brookstein, who's our Senior Associate Dean and also a Professor of Mechanical Engineering. Dr. Daniel Jacobs, who's an Assistant Professor in the department. And then finally, PJ Williams, who's one of our current students and is also a junior. And PJ will be speaking to you later in the session about what he does within the department, and if you're interested in learning a little bit more about what the student experience is like. So real quickly before I turn it over to our faculty, just some quick information about Temple's College of Engineering. We were founded in 1969, so we just celebrated our 50th year, which is really exciting. And we have about 1,700 total students within the college, so about 1,500 undergrads and just under 200 graduate students. And depending on the size of your high school, that number might sound big to you, that number might sound small. But when you compare the size of the College of Engineering to the rest of Temple University and some of the other schools and colleges, like, for example, the College of Public Health or the School of Business, we're one of the smaller colleges. And Dr. Brookstein will talk in just a little bit about some of the advantages to that. So you really get the best of both worlds by being an engineering student at Temple. Our undergraduate student body is about 25% female, which is above the national average, which is really exciting. The national average tends to hover around the low 20s. I think maybe 21, 22% is the latest. And we also have a highly diverse student body. 37% of our undergraduate students identify as non-white, and we also have students that come to us throughout the globe. We have 136 international students that are currently studying with us. And here's just a little bit of information about the Department of Mechanical Engineering. It is our largest undergraduate major, so there's about 464 total students in the department, both undergraduates and graduates, but you can obviously see that undergraduates make up the majority of students in the department. We have 438 undergraduates that are currently declared as mechanical engineering students. The department is 15% female, and our diversity numbers kind of mimic the rest of the college. So about 38% non-white and 35 international students within the department. So now I'm going to turn it over to Dr. Jacobs, who's going to talk a little bit about the faculty in the department.
Hi, can everyone hear me well?
Yep, you're all set. And when you're ready to advance to the next slide, just say next slide and I'll take care of that.
Okay. So yeah, my name is Daniel Jacobs, and I'm going to talk a little bit about our faculty. We have 5 areas, and so we're going to talk about 3 of the areas now. Some of them are sort of applied biomechanics. These are things related to tissues, solid modeling. You might look at this research and see it in the design of cars, the design of safety equipment, in the design of medical devices. And this applied biomechanics side works really well with our material science side. So we have a group of faculty who look at things related to stress and strain, related to energetic transformations inside carbon fiber, inside magnetic-based solids. And so we have a group of faculty doing research in that area. And we also have a sort of thermal fluids, renewable and alternative energy group that is composed of, again, a lot of really interesting research related into protecting batteries inside cars. How do you generate wind energy efficiently? And how do you manage heat and energy transfer through fluids? So next slide, please. And so our last 2 areas are sort of the classic thermal fluids transfer. This includes faculty who have worked on combustion inside engines, and we also do thermal fluids. So think about if you have the equations related to how fluids move throughout the body. So for example, Dr. Kiani does a lot of interesting work looking at how you may be able to build a lab on a chip. What are the ways in which you can detect diseases, you can detect foreign materials inside small laboratories. A lot of his interesting work is related to sepsis. So if people are, in danger of having their nervous system shut down because of foreign objects in the body, could you detect that quickly? Could you test drugs faster inside these miniature chips? and be able to improve human health through this research. And then our last area is in dynamics and controls and robotics. That's the group that I'm in. And so in this area, we are looking at, for example, how robots can partner with humans inside multiple spaces. So in my lab, this is about how do robots and humans walk together collaboratively. In Dr. Dame's lab, for example, it's about how swarms of robots can be used to give information, whether they are unmanned underwater vehicles, air or terrestrial vehicles. We also have faculty who work in acoustics, for example. So how can we take the inspiration from nature around us and build sensors that are inspired by those designs? And then we also look at dynamic systems together. So when you have multiple sensors or multiple robots and they all have noise, they all have an incomplete picture of the world, how do you bring them together in order to make a really truly intelligent system? So those are our 5 areas. And I guess what I want to leave you with is there's overlap between them. One of the best things about mechanical engineering is that we are very broad. We cover things that move. And so that means you could be ME and be interested in BioE and think about medical devices. You could do mechanical engineering with computer science or electrical engineering, which is the robotics group. So ME gives you a really great background. But then in here, inside our department, you get a chance to actually follow your interests and be in a lot of different interesting areas. Pass it back over to Dave now. Thank you.
So now we're going to turn it over to Dr. Brookstein, who will talk a little bit more about, what is mechanical engineering and some of the skills you'll pick up.
Well, thank you, Colleen. I'm going to first get personal. Dr. Jacobs mentioned bioengineering and the devices that mechanical engineers work on associated with medical devices. You're looking at a guy right now who's over 70 years old. 3 years ago, I had major open heart surgery to replace my aortic valve. And actually, Dr. Kiani works in this area. And it was a device that was designed by mechanical engineers. And it was a very gruesome surgery. Obviously, I survived it. But now they have an alternative way to do it, where they can, instead of opening up your chest cavity and opening up your heart, they can insert a artificial heart valve up through your leg and then expand it so it goes into your heart and pushes away the old valve. That's amazing. That's amazing. And I had this operation 3 years ago. They say that the device I have lasts between about 14 and 18 years. And I asked my surgeon, well, what happens then? Because I'm planning on staying around a long time. He says, oh no, then we take that new device that we just developed and we insert that and push away the old valve, and then you'll get another 10 or 15 years. So what I'm really concerned about is when I'm 100, what they're going to have then. But hopefully you all will be on the vanguard of developing the next biomedical device that uses mechanical engineering to do that. Another thing I want to mention is, yes, we are the grandparent of engineering disciplines. We, along with civil engineer, was the first kind of engineering that came about. And as the slide says, we use the principle of energy, materials, and mechanics to design and manufacture machines and devices of all types. Let me take a minute and talk about design. Now, many of you probably have in your mind what you think design is. You're going to do some drawings, you're going to do some problem solving, and you're going to design something. But today, in our department, mechanical engineering, along with all the departments at Temple University, we start everybody in the first course you take, the very first course you take, called Introduction to Engineering and Engineering Technology. And we teach you the concept of something called design thinking. Design thinking involves 3 steps. The last step, which is when I studied engineering right around the end of World War II. Well, I can't hear anybody laughing, but usually people figure out it was a little bit later than that. It was all about solving problems. And certainly Dr. Jacobs told you all about the different courses that we offer. And a lot of those courses are what I call transactional courses. They teach you how to solve problems. Very, very important. but it's not enough today when you're an engineer. You have to start from day one thinking like a design engineer, and a design thinker. And when you're a design thinker, you start by identifying the needs. I'm going to tell you an example of that in a minute. You identify the needs, then you clarify and define the problem, and then finally you solve the problem. And we've now embedded that thinking in all of our courses, not just the mechanical engineering, but throughout the College of Engineering. And we're very proud of that. And we continue to refine design thinking so that our students can go out and be design thinkers and use all the transactional methods that they learn that Dr. Jacobs told you about, but be a much more valuable engineer. And as such, you'll then be able to create the processes and systems that drive technology and in industry. I mentioned identifying the need. You probably have all heard about this COVID virus that's around. Well, when COVID first was really became, we recognized it was a pandemic, people started to say, well, we need masks. Unfortunately, there was a shortage of masks. The only masks they had were, you've probably heard this in the news, were the N95 masks. And those were in short supply, and they were kept for medical workers. They needed them. Well, most of us aren't healthcare workers. So you couldn't buy a mask. And I used design thinking to design a mask. And we did that. We eventually made 10,000 of those masks, and actually the volunteers at the medical school made 10,000 of those and distributed it to them to the residents of North Philadelphia. Well, now you can buy masks anywhere. And I continue to do mask research, and I have since identified other masks that are now readily available. But it started with identifying the need. In this particular case, it was very easy to identify the needs. Some of the needs that you'll learn how to identify aren't so obvious. And as engineers, that'll be a real opportunity for you to identify needs. Every engineering school in the country, every mechanical engineering school in the country teaches all the transactional courses that we teach. And I don't want to de-emphasize the importance of them, but that is not enough to make you a successful engineer today. So we've embedded design thinking throughout the curriculum. Next slide. So some of the things that we work on is advanced machinery. That's becoming more and more important today with things like autonomous vehicles. You're all going to be not driving, you're all going to be in autonomous cars. That's coming. Even today, we have semi-autonomous cars. If any of you or your family have purchased a car in the last couple of years, there's so many items on that car that is advanced, such as blind spot indicators, automatic braking. I have a car where if I start to move out of the lane, it knows that I'm moving out of the lane. It senses that and forces my steering wheel to turn and put me back in the lane. You've probably seen this ad on TV where this family is not really paying attention. They're backing out of the driveway, and all of a sudden, a kid on a bicycle comes across the back. The car automatically brakes. That's called reverse automatic braking. That's all mechanical engineering, and included certainly electrical engineering and computer science. But what's important is to know that all these things work together. And then back to the transactional part, we have to know how to graphics and computer aided design today. And today you can do not just computer aided design and have what it looks like, but you can show how something might move or work or interact with another mechanical part. And then lastly, another area is robotics, which Dr. Jacobs is very active in. That's becoming more and more important today as we're trying to bring back more industry into the United States from overseas. And because our cost of labor is relatively high, it's important that robotics play a part. So if you go into a modern automobile factory today, the vast majority of the automobiles assembled by robotics. Mechanical engineers are behind all that. Next slide. So why come here? Why come here? You go to a million engineering schools. Why come to Temple? Okay, there's a lot of reasons why you want to come to Temple. Colleen mentioned one thing already. We're a relatively small school in a university that has about 30,000 undergraduates. So what happens is when you're in the Temple College of Engineering, you're kind of like in a small university, a small college. So everybody knows you. We all know all the faculty. We know all the students. We know everybody. They all know us. We interact with the students all the time. But at the same time, you'd be coming to a school that has a Division I football team. Not a great team this year, but we've had very good teams. We beat Penn State about 3 years ago. So you have the football team. We have a world-class library. It was just completed last year. It's won all kinds of awards from both library associations, architecture associations. It's world-class. And in that, you're able to access virtually anything electronically. So right now we're in the COVID situation and the library is closed. Hasn't affected the students at all because they can access almost any journal, almost any book electronically. So you get the advantage of a big university, but you're actually studying in a small college. So you get the best of both worlds. We have an accelerated program. So today we have a lot of students and each year it grows more and more. Generally, if you follow your schedule, you'll be able to get a BS degree in 4 years. Generally, if you want to get a master's degree, takes 2 more years. 4 + 2 is equal to 6. But we have an accelerated program, we sometimes call it the 4+1 program, where in your senior year, you can start taking graduate courses in mechanical engineering that can be used for credit for your bachelor's program, but also gives you a head start in getting a master's. So after 1 year, instead of 2 years, you can get a master's degree. Well, obviously, it's going to cost less because you're only going to pay 5 years worth of tuition, but also it gives you 1 more extra year in your career to work. So we have more and more students doing this accelerated program. We also have a campus in Rome. It's called Temple University Rome, and we have a program so that you could go to Rome. It's generally in your second semester of your sophomore year and take Temple courses that are identical to the courses you would take if you were on main campus. So you could be in Rome. I think we have 3 courses in mechanical engineering. Also, the civil engineers could take the same courses. And also, then you would take maybe what we call a general education course, which is a requirement at the university. Like you could study Italian or something that is not related to engineering, but you could go to Rome. Tuition's the same as if you were at main campus, but you're in Rome for a semester. How bad can that be? I mean, I love Rome. Unfortunately, I've been there this year because of COVID, but by the time you get here, I'm sure you'll be able to do Temple Rome if you're interested in it. Dr. Jacobs mentioned research. Generally, when you think about research, you think about, well, that's what the graduate students do. So what does that have to do with me? Well, it turns out that undergraduate engineers who actually do research generally get a more extensive and intensive education than those that don't do undergraduate research. So many of our students partner up with both graduate students and faculty to do undergraduate research while they are studying their undergraduate program. Last one I want to mention is co-ops or internships. While Temple isn't like an engineering school I heard of down the street from us, Drexel, which requires a co-op, we do not require a co-op, but we offer a co-op if you're interested. Frankly, we don't have a lot of students doing that. Instead, what they do is they do internships. And I think this year we had over 100 students actually doing internships with both local and companies all over the country. We had a student for 3 summers. She was an intern at Tesla. And what happens is when you do an internship, it certainly enhances your education because you get what we call experiential learning, but it also, a lot of those internships turn into full-time jobs. Along with that, we have career fairs. I first joined the university about 6 years ago, and we had just started having career fairs. These were career fairs that were specific to the engineering college. When I first started, I think we had 20 companies come. Now it's more than 75. It's closer actually to 100 companies across the spectrum. Companies like Boeing, small companies, General Electric, Comcast. They're interested in our students, and they come to the career fairs. And as a result of that, they get jobs or get in the door, and then it's up to them to pursue once they do that. And some of those just lead to internships also. And in red, we have 72% of our students report participating in one or more experiential learning opportunity, which is essentially an internship. Is that my last slide, Colleen?
Yep, so now Dr. Jacobs is going to take over and talk a little bit more about opportunities for students with research and senior design.
Yeah, let me just say one thing, everybody. I'll be on the whole thing. So if you have, I guess we're going to have a question and answer session at the end, Colleen?
Yes, that's right.
Okay, all right.
All right, thanks, Dave. I want to just follow up on that last slide and say, I'm also looking forward to answering questions later. I've had a lot of summer research students, 2 or 3 in my lab each summer. We even brought in some high school students as well. It really is a great opportunity to do hands-on work. I've also had several students in the, and currently in our +1 accelerated master's program. So I'm happy to answer questions related to that too. So I talked about a lot of these different projects, but now I get to put them, in a little bit more context with photos, which is always helpful. To follow up on what Dave said, really what is design thinking? What is our role as an engineer? And as he said, we're problem solvers. And one of the major differences is that when we come out of our bachelor's degree, it's meant to be a terminal degree. You're supposed to go right from there into your job. Well, what are the things, right? When we live across the US, there are thousands of colleges, and we have a lot that are very close to us as well too. So what are the things that you can do to separate yourself? Well, like Dave said, it's about experiential, it's about hands-on learning. Can you show your potential employer that you've actually taken your knowledge out of the classroom and put it to use somewhere? If you do it in an internship or in a research lab, great. But I think one of the things that sets us apart is how well we can get our students into these opportunities. So if you're interested in research, I think you should definitely spend some time exploring the labs that we have in Temple. So in the mechanical engineering department, you can see 4 pictures here that really show you how much ME interacts with other departments as well. So I'm going to start sort of from the top right and go clockwise. As we said, we have the Trail Lab in case you're looking for it. We have a lot of lab websites on our Google sites. Dr. Dames runs this lab, and you can see a picture of a turtle bot coming in the doors of the College of Engineering. So a lot of this work is saying if you plopped a robot down in an environment where you don't know where it is, and it has a laser rangefinder on top, it has the ability to move around, can you get this robot to figure out where it is in the space? It doesn't know where the walls are. It doesn't know where people are. But can you refine the algorithms that allow it to safely navigate the space? And as Dr. Brookstein pointed out, this detection, these sensors, the decision-making process are showing up on cars, on things in the real world. And so in the research lab, what you see here is the creation of the next generation. How do you make it even more safe, even more robust? Going down the picture, you can see me. I'm bending down here and I'm putting on a pair of ankle exoskeletons on this, one of my students in the research lab. So we all have seen, and thanks to Marvel, and maybe even more so that we've been stuck at home, there's been a lot of interest in Iron Man and the thought of what can exoskeletons do. Well, I'm very happy to say that there's still a lot of research to be done in exoskeletons. We're not ready to jump out of skyscrapers and have things connect to us as we fall to the ground. But for me, the fundamental question I want to answer is, how do people with impairment, if you've suffered a stroke, if you have lost some muscle or lost a leg to amputation, if you are suffering from a chronic disease such as multiple sclerosis or cerebral palsy, being able to walk, being able to navigate in your community is just a fundamental act of living that we want everyone on Earth to be able to enjoy fully. So here you can see this person has these carbon fiber ankle exoskeletons, because in order to get from where we are to Iron Man, we have to understand more about the human body. A robot by itself is not going to be intelligent, but how can we take signals from the human body to make the correct decision so that our exoskeleton pushes at the right time during walking? If you push at the wrong time, you're not helping the person. You're actually making a really crazy sort of exercise device. So being able to understand ME and BioE, that's sort of where I land. Dr. Darvish here with the ejection seat is again a classic sort of what we call solid mechanics. It is about making physical systems, figuring out how to get information from them. We can't put a sensor everywhere in the body, but what sort of sensors could we put on the person, could we put on the dummy, allowing us to model the forces and the energy that happens in these ultra fast collisions? So can we model these ejection seats? Can we figure out how to better design them so that when they have to be employed in emergencies, we can increase the chance that the person gets out of there safely and reduce any secondary injuries? Our last device is Dr. Liu. And as we said, he is our faculty that is an expert in acoustics. So he looks at a lot of small insects and other animals and has created these match size. You can see there's a 2 millimeter sensor down there. And in that sensor, the idea is that this is a sensor that could go on these different robots, whether they're small flying or small moving terrestrial robots, and use this to understand what's happening in the world around them. Use it to determine, are you close to a wall or not? Because the sound echoes differently when you're far away from walls or rigid objects to when you're close by. So by increasing this next generation idea, creating more sensors for the future, we'll be able to take all of these systems and make them smarter and make them more effective. Next slide, please. There we go. And so one of the main things that makes engineering different, and this is across all of the engineering disciplines, is that your final, what they call the capstone. So you have come up through the ranks, you're now at the top of the pyramid, and your last project, one of the things that's really critical for when you move on to your job is this idea of your team-based senior design project. At Temple, we do this over 3 semesters, so we invest a large amount of time into these projects. But students form cross-disciplinary teams, and they are trying to solve an unknown question. So it may be an industry sponsor that's saying, hey, I would like to make this object. The thing that we have breaks too often. It could be a research faculty that's saying, hey, I want to design a better rig to detect this data so I can make better decisions in the lab. But through this whole experience, these teams of 4 get about $1,000 to go and try to solve, to fully design a solution, create a prototype, and test that prototype in the hopes of solving that problem. It is a great experience. It is challenging. It is exciting. And most importantly, it's very close. It's a real world look at what you'll do as an engineer. There's a huge difference between a real world problem and a book problem. And so we have this great senior design that can help push you toward putting these things into action, giving you the hands-on experience necessary when you go to apply and start your career. So they build first a set of specifications, right? Because one of the things you'll have to do as an engineer is your client will have a list of wants, and it's your job to turn them into quantitative numbers in engineering. Oh, what this person means is it must hold 100 newtons. They said they wanted it strong. We as engineers need to put a number there. Then in consultation with your technical advisor, a coordinator, and your sponsor, whoever it is, you continue to refine that over time. You go through this design cycle of generating ideas, evaluating them, testing them, right? The goal is to move through it as quickly as possible. And along the way, you practice giving presentations. We've had many students who have, their groups have worked for these national and regional competitions, for example, ASME, ASHRAE for civil engineering or IEEE have student design competitions. So if you present a good design, the college supports you. They will help. If you get selected to go to this conference, the college will help fund your way to go represent Temple at these competitions. And in some cases, these senior designs are presented as part of research findings at academic conferences as well. Thank you. Next slide. I think there's one more. And so here are some examples of a bunch of different projects. The top one you can see is a group that's designed their own quadcopter, trying to find ways of making it more stable and more robust so that a single quad drone or multiple drones could be used together for search and rescue. This middle group, as you can see, is one of my senior design groups. We've run this a couple years. This is our second time. There are many, many students who are unable to participate. If you have temporarily, you can make different, adaptive pieces, allowing everyone to sit on their couch and play games together. So design is this really interesting thing. It is problem solving. So I'll pause for a sec. Thank you. And then in addition to these kind of individual projects where sponsors have come to us, we have really classic senior design, classic student groups. We have a Formula SAE team. It's composed of many, many students. And so students will take their senior design and usually try to update one area. Maybe they care about the suspension. Maybe they want to design better damping so that the car handles better in turns. Maybe they want to improve the braking or other control that goes inside the car. So we have a lot of projects. They come from a lot of different areas. And again, they really are going to give you that hands-on experience that's needed to separate you from just someone who has taken the classes. Thanks.
Great, thanks, Dr. Jacobs. And I apologize, my internet was shaky for a little bit there. That's one of the delights of working from home and working during COVID. So I apologize if we lost the slides for a couple seconds, but it looks like we're back on now.
What that really is she lives in Fishtown and they only have one antenna for about 500,000 people.
That's not true.
Tell the truth.
I bet we have more than that, but
tell the truth.
Yeah,
okay, go ahead.
It's the joys of Comcast internet. So if you all become mechanical engineers, hopefully you can go on to work for Comcast and better the Wi-Fi. But anyway, one thing I also want to mention is we have a number of student organizations based in the College of Engineering, and this is just a quick snapshot of some of the ones that might apply if you were to study mechanical engineering. So you see here ASME, which is the American Society of Mechanical Engineers, Temple Formula Racing, Dr. Jacobs touched on that just a little bit. And we also have sort of social organizations, not just professional organizations. So you can see here SWE, which is the Society of Women Engineers, NSBE, which is the National Society of Black Engineers. I believe all total at the College of Engineering, we have over 15 or 16 student professional organizations. So we highly, highly, highly encourage you to get involved, both to expand your professional network as well as, to meet your students in other majors, because, the great ideas that you come up with as an engineer, you can see it's highly collaborative. So it's important that you associate with the electrical engineers and with the industrial and systems engineers, but also to get outside your comfort zone within all of Temple. So get involved with some of the many different organizations that we have throughout the university. And we even have students from other majors at Temple join some of our student organizations. I believe the past president of Temple Formula Racing from last year was actually a business major, because they need people to help them out with their financing and keeping their books and such. So absolutely get involved both within the College of Engineering as well as at Temple as well. Oops, skipped ahead a little bit. And finally, what happens when you pull this all together, when you graduate in 4 years, what happens? So this is our most recent graduate exit survey. The class of 2020 data should be available to us probably in December or January. We survey our students 6 months after graduation, but these numbers have very clearly gone up from the last year or so, but 6 months after graduation, 85% of our students in the class of 2019 employed that they were working full-time or that they were enrolled in graduate school, whether that be a master's program, a PhD program. We have students that go on to medical school or law school. So engineering opens up many different pathways for you. They had an average starting salary of $60,000, and that's actually the highest level of salary measured on the Temple University Graduate Exit Survey. And engineering graduates rather, traditionally have some of the highest starting salaries for all Temple graduates. So, and one thing we didn't mention is that Temple's mission is all about offering, really high quality education at an affordable cost. So you'll absolutely see a return on your investment and get a really great value for the education that you receive at the College of Engineering. And you can see here, over half of our graduates last year, 57% of respondents reported a starting salary of over $60,000. So, engineering is it's a really great profession and a really great degree, and you'll, certainly be seeing a return on your investment, which is really exciting.
Can I say a few things, Colleen?
Dr. Brookstein.
Yeah, okay, a couple things. Dr. Jacobs mentioned several times the word multidisciplinary. That's really important today, because today's engineers don't work in silos with, let's say, if you're a mechanical engineer, I can assure you, you're not only going to work with other mechanical engineers, you're going to work with electrical engineers, you're going to work with industrial engineers, you're going to work with bioengineers, you're going to work with civil engineers. So we want you to start thinking multidisciplinarity to begin with. Now, there's another thing too. I talked about design thinking, and I didn't mention something that's important. Colleen clearly showed that we have a diverse, or she had the numbers that showed we have a diverse student body. Very diverse student body. That's what I call social diversity, okay? But we also have within the university something that I call academic diversity. And what I mean is we have, dance and music and art history and business, law, medicine. And why is that important? Remember I told you a little while ago about design thinking and identifying the need. Sometimes the need will be identified by not an engineer, someone that is, let's say, a architecture major might identify a need. Someone that's a business major might identify the need. So Temple University has 17 colleges and schools. So definitely we have a very socially diverse student body. We also have an academically diverse student body. And that is really, I think, one of our secret sauces. One other thing I want to say, so I don't want to forget it. It has nothing to do with this lecture. Nothing to do with this lecture, but it might be the most important thing you're going to hear tonight. Make sure you always wear your mask, okay? Wear your masks. Take that seriously. A study was just published on Friday from the University of Washington that if we had 95% of the people in this country wearing masks, we could save 140,000 lives, okay? Wear your mask. Okay, that's enough preaching. I'm done. I'll answer questions about engineering if you want.
Thanks, Dr. Brookstein. So before I turn it over to Peter, here is all of our contact information. So any general emails you can send to the undergraduate address you see there. But myself, Dr. Brookstein, Dr. Jacobs, feel free to reach out to us after this session if you have any questions. But right now I want to turn it over to our student, PJ, who's going to talk a little bit about what it's like to be a student in mechanical engineering. So Peter, PJ, whenever you're ready.
Hey guys, my name is Peter Williams, but most people call me PJ. I'm a junior mechanical engineering student at Temple, and I also have a minor in theater, so that's some multidisciplinary right there. I am currently a recent inductee of Pi Tau Sigma, which is the Mechanical Engineering Honor Society. I'm also rushing Theta Tau, which is the co-ed engineering fraternity we have on Temple's campus, and I'm also the vice president of the American Society of Mechanical Engineers of Temple's chapter. Just a little, I guess, information on me. I'm from Ridley Park, Pennsylvania, so I live about 45 minutes out of the city. So I kind of grew up in the area knowing of Temple, but I wasn't really like looking to go here right off the bat. One of the things that really sold me to be a Temple student was the campus feel. I really liked that I get to be in the city and I still get to be on campus. I currently live I'm home right now, but I currently live off campus in an apartment that's about a block off campus. So if you guys have any questions about just like life in the area, whatever, I can help you with that. I guess the most important thing I have to tell you guys would be that with engineering, it's important to build strong connections because engineering is tough. I'm sure you guys know that it's not going to be in like a cakewalk, but engineering, the biggest part of engineering to me is the connections and the people I surround myself with. Like I said, I'm a part of a couple organizations, and through those organizations, I have made tons of friends. I've communicated and built relationships with tons of staff members and other colleagues. And it's really nice to be able to walk into a classroom or a meeting and see someone that you already know and that you can just branch off of when it comes to studying or doing homework or asking questions. And yeah, it's really nice that's one of the things that I love most about being a student at Temple is that there are tons of resources out there for you to succeed. You just have to use them.
Great, thanks, PJ. Now,
PJ,
if any of you,
can I ask PJ a quick question?
sure.
PJ, you're studying theater. Did you take an improv course yet?
I'm studying technical theater, so I'm working on like design elements.
Okay, but take an improv course. I took 2 years of improv and it made me a better engineer. Trust me. And that's for anybody else. Take an improv course. Okay, back to Colleen.
Thanks, Dr. Brookstein. So if anyone has questions, you can type them in the Q&A section of the Zoom. So when you hover your kind of mouse over the controls, you'll see that. And it looks like we have had a couple questions come in. And Dr. Brookstein, you might be able to answer this, and I think the answer is yes, asked by Logan here, is Temple Formula Racing still able to compete with COVID? I know they're still working in the building, but I'm not sure. The competition is a national competition, so we're kind of unsure of the fate of that at this point.
No, we're not doing that this semester or probably next semester also. Logan also has asked the question, how hands-on are the courses? Should I answer that, Colleen?
Yes, if you don't mind.
Okay, so we have, even though we're essentially, I'm going to use that word twice, essentially off campus now, we were permitted, and not just us, other schools at the university, to offer what we call essential courses. So for instance, senior design, that is an essential course, and it's essential also that the students be able to build things in what we call our Ideas Hub, which is about a year old now. IDEA stands for Innovation, Design, Engineering, and Applied Science. So we do have special permission from the university to let students work in those labs. They can also do some work in the machine shop. As you might guess, this is a really difficult time right now, but we convinced the university that these are essential. The students, they're not going to be engineers unless they really can do a senior design course. So they're letting us do that now. And of course, we require not only them to wear masks, but we made face shields. In fact, the face shields that we made were so successful that we ended up making tens of thousands of these for across the university, and especially the hospital, Temple University Hospital. Again, we're talking now April, May, when a lot of this PPE, personal protective equipment, wasn't available. Our engineers stepped up to the plate, and we made the clear plastic face shields that they wore. So by the time, hopefully, by the time you all come to see to us, would be fall of what, 2021, Colleen?
That's right.
Yeah, we should, fingers crossed, this COVID situation should be, I'm not going to say eliminated, but it should be under substantial control, where it's not as serious as it is now. So I think, to answer your question, you're going to, our program has a lot of lab work in it. You saw a lot of it from Dr. Jacobs, and by the time you guys get here, I'd say about 98% sure we'll be open. Now, you might be wearing masks for the next 10 years, frankly, but you'll be here. You'll be here. Also, I see another question. Is mechanical engineering the most hands-on type of engineering? You know, I don't think I could say most means that's pretty absolute. It bioengineering has a lot of hands-on. Civil, a little bit less. Electrical, a little bit less. But mechanical and bio are probably at the top for hands-on. But again, back to senior design, that's for everybody. And that's all, not all. There's a lot of hands-on engineering there. You'll get a lot of hands-on activity though in mechanical engineering. I can assure you that. I'm a mechanical engineer, so I think I know what I'm talking about. I have 13 patents, and every one of those patents came about because I made something. And I got a patent on it. Okay.
Thanks, Dr. Brookstein. Looks like we have another question. Do you offer mechanical engineering classes at the Antler campus? We don't offer engineering courses at Antler. However, depending upon whether or not you're ready to come immediately to Temple, or you might want to take some time and take classes elsewhere, we do offer dual admissions with Montgomery County Community College with their mechanical engineering program. If you get your associates at Montgomery County in mechanical engineering, you pretty much seamlessly walk in the door with junior level status as a student at Temple. And there's also additional scholarships available for dual admission students. So that's something to possibly look into if you're not quite ready for the kind of big urban campus experience just yet. So that's something to look into. Another question I could take. Sorry, Dave, go ahead.
You could take courses at Antler, but there won't be engineering courses. But we require, as just almost every university in the United States, we require what we call 8 gen ed courses, general education courses in various groups in let's say history and psychology and what have you. A lot of those are offered up at Antler, but you won't really have a chance to take engineering courses. Colleen mentioned Montgo. We also have agreements with Bucks, Delco, and CCP.
CCP, right.
Yeah.
And this question, are you requiring SATs for the 2021 school year? So Temple is a test optional university. So you are not required to submit SAT scores. If you feel, however, that the SATs would help enhance your application, then certainly you're more than welcome to submit those. I will say that the engineering college tends to have one of the highest SAT averages for all incoming Temple students. I believe our average SAT for this year was, I'm not sure what the actual verbal quantitative breakdown was, but I believe we were at around maybe like between a 1260 and a 1270, whereas Temple as a whole is, I think, around maybe a 1210, 1220. So we're at the higher range of that. But again, we are a test optional university, so it is completely up to you whether or not you want to submit SAT scores.
But I want to just throw something out there, which you might have heard me say at our virtual open house. I'll say it again. One of the languages of engineering, one of the primary languages, is mathematics. Now, you don't have to be a mathematician to be an engineer. I have a doctorate degree from MIT. I'm the farthest thing from a mathematician, but I always felt comfortable in math. I never was afraid of math. I learned that to do well in math, it requires practice, no different than if you want to be on the football team, you'd be practicing plays all the time. But I have had, in my role as the senior associate dean, last year I had a student, I didn't even know what to say to her. She comes in my office, she's telling me she's having problems. I said, well, how about math? How are you doing in math? And she looked me straight in the eye and she said, well, I hate math. And I was polite. But the little balloon over my head was, then what are you doing studying engineering? My point is, we'd love to have all of you come and study with us, but don't come to not just our school, any engineering school, if you're not, and this is the important word, if you're not comfortable with mathematics. You don't have to be a mathematician. God knows I was not a mathematician, but I never was afraid of math. So it's just a little piece of advice I want to give everybody. I don't want to see you waste your time or your money if you're not comfortable in math, but you don't have to be a mathematician. Get my point? Okay.
Great, thanks, Dr. Brookstein. As we're waiting for more questions to come in, just kind of as you're all kind of considering, engineering and different engineering programs, PJ, what made you decide to study mechanical engineering as opposed to, let's say, like electrical or bio?
Sure. To be honest, I really don't know where the idea came from. I just remember like junior year of high school, I started to like consider engineering. I'm not sure why, but the more and more that I thought about it, the more I liked it. One of the most appealing things of engineering and mechanical engineering for the most part to me is the hands-on aspect. I tend to think physically and just like how things work, how things function and go together. And so that kind of drove me to pick mechanical engineering. A big draw of engineering and its whole for me was the fact that like it's never finished, and like as like the world evolves and as science continues to evolve, like engineering, there's always going to be engineering, and there's always going to be a need to improve or enhance like the way of life. And the fact that like there's always going to be another challenge waiting for you, like that just appeals to me. And I like the idea that I'm never going to have to like settle with engineering.
Yeah. Now, but PJ, and this is for everybody. You said the world's always changing. Okay, I got some good news and bad news to give everybody here. Okay, everybody. I don't care where you study engineering. I don't care where you study engineering. 50% of what you learn is going to be out of date in 10 years because technology is evolving so fast. So what's also very important, and I think we do a pretty good job at it, we teach you how to learn how to learn. I've had so far, I've had a 45-year career. I do things in engineering that I had absolutely no education in because it didn't exist when I studied engineering. I studied at Georgia Tech. It didn't exist undergraduate. It didn't exist, but I learned how to reinvent myself. I learned how to learn because one of the things that's important in engineering education is teaching you how to think like an engineer. And at the end of the day, to be honest with you, it doesn't matter so much if you end up studying mechanical engineering and 10 years from now you're working in civil engineering. Related to that is the following. Our first year of your education at Temple in engineering is essentially identical no matter what major you choose. So let's say tonight you say, I want to be a mechanical engineer and I want to come to Temple. God bless you. We're looking forward to you coming. But let's say when you get here, you decide, I've been in that introduction to engineering course where we talk about all the different kinds of engineering, and I think electrical is more interesting to me than mechanical. Great. Better to know that at the end of your first year when you can make that change seamlessly. We don't have any quotas on our different disciplines. So you can't, let's say you signed up to study mechanical and now you think you'd rather be an electrical engineer. We don't say, oh, but we're sold out in electrical engineering. Well, you can switch after your first year. You can switch after your second year too, but then you might have to go back and take some more courses. But if you take the first year is essentially identical for all our undergraduate engineering programs. So if you're let's say, hey, I know I want to be an engineer. I know I want to be an engineer, and I'm pretty sure I want to be a mechanical engineer, but I'm not 100% sure. Temple's a good place for you to come because you can switch without essentially any cutting back in terms of what or having to take additional courses. So keep that in mind. Because look, my guess is most of you are somewhere between 17 and 18 years old, and that's a tough time to know exactly what you want to do the rest of your life. But I also have to tell you that research shows that about not only does what you learn go out of date after about 10 years, and we can't help that because technology keeps evolving, but something like 80% of engineers, students who studied engineering in a particular major, 80% of them after 10 years, they're still engineers, but they're working in a different discipline. So in other words, a mechanical engineer might find that he or she, after 10 years from now, is working for Turner Construction as a civil engineer, okay? And it's possible to do that because the basic tools are learning how to be an engineer. That's what we're going to teach you, how to be an engineer. And if you can learn one particular area, you'll be able to relearn or learn another area. So this is a good place to get, a great place to get that kind of background, okay?
Great, thanks, Dr. Brookstein. Dr. Jacobs, how about you? Why did you decide to pursue mechanical engineering and engineering as a career?
I think everyone covered it really well. It is a beautiful thing to come to a college that lets you explore and has interesting stuff in a lot of areas for you to explore. So much like PJ, I was like, I think I'm going to be a ME. All right, I'm going to go and do this engineering thing. When I got to my alma mater, which was out on the West Coast, it was all about trying different things. So I took some electronics classes. Maybe I want to be an E. What's electrical engineering about? Maybe I want to be a doctor. Let me take some of this chemistry. Let me keep sampling as much as I can. There was a program in science and technology and society. I'm like, oh, I really like engineering, but the way policy and the way we think about ethics in science was also really interesting. So I really got to explore a lot of different things. And that's what these first 2 years are about. Your engineering courses come later. In the first couple years, you're taking calculus, you're taking math, and you're taking physics. Those are the sort of the underpinning. That's the foundational knowledge on which we can build engineering. And so you definitely want to be willing to learn those, right? Maybe you're not comfortable yet. I think in different days, I'll say you may not have to start out perfectly comfortable, but you've got to have the energy, the desire, the will to get comfortable by the time those engineering classes come, because we're going to build on that foundation.
I agree.
And so for me, the thing that was inspiring was being able to look in the research labs. And so I want to bring it back to that, to say, yes, okay, I'm doing well in my classes, but the thing I want to learn, the thing that brings us to a university is a desire to learn something. It's not just about improving ourselves. There's some piece of knowledge that we can't get, and we want to be in a university with faculty that care about us, with students that are energized, so we can actually learn that thing. That's what got me into mechanical engineering, and that's what got me into grad school as well too. There was a research lab that did legged robotics. So if you've seen the Boston Dynamics, these quadrupeds and all these other robots coming around, there was a lab building a 4-legged robot, and they wanted to get it to bounce. And I just loved looking into that lab. And so I finished my undergraduate degree, and I said, I still don't know how to do that yet. And so that's when I started to follow up and learn more about robotics, went into grad school for robotics, to get to the point where Dave Brookstein said, I was ready to learn on my own. And what I wanted to do was be in this new field that was combining human-centered ideas, biomechanics, locomotion, walking with the robotics, and say, that's where I want my career to be.
Daniel, it's interesting. In design thinking, we say that one of the keys is to deal with enduring human needs. And it sounds to me like you are right on top of that. So
that's right.
Yeah.
We have people who are impaired. They can tell you what their problem is. They cannot tell you the solution.
Right.
So what do? Design thinking, the first thing tells you to need find. It says, get out of your books. Go talk to that person and interview them. Watch them, shadow them for a day, figure out the things that can't be done, figure out the problems. Are they having trouble turning open a door, right? Are they having trouble hitting the buttons in the elevator, putting a USB stick into a computer, angling their camera for their Zoom class? There are needs, and those needs will always persist. That's a great thing, because there will always be need for engineers to solve the next generation of problems. The thing I sort of want to end on, and I think Dave covered this excellently, the problems that we were able to solve as individual engineers doing just our discipline are gone, right? We have now grown past that. The problems of the world that we have today, the ones that are upcoming, involve this multidisciplinary work. So the most important thing is to realize that you're coming to ME because that's where you want your expertise, but you are going to be in a company that's going to put electrical, mechanical, bio-e, computer scientists, mathematicians, whatever it is, together, because they know that team will solve their problem, not you specifically, mechanical engineer. So learning to work together is so critical to where we need to go in the future.
Great, thanks, Dr. Jacobs. It looks like we have one more question come in, and this is a good question from Shane. Are in-persons available now or during the spring semester? In-person visits have just started, and they're being given by undergrad admissions. So if you go to undergrad admissions' website, I believe they're offering tours twice a day at, I think, noon and 1 p.m. or noon and 2 p.m. And there are some visits available on Saturdays as well. However, there are limitations to that. I believe they're only going to be allowing 2 families per tour, just to be able to maintain social distancing, and you have to wear a mask and such. And the tours are strictly outdoors right now. We're trying to, again, limit, exposure and such. So we haven't yet decided at the College of Engineering when we'll be starting back visits to the college, like to see our labs and to see our facilities, just due to COVID issues. But you are, more than welcome to schedule a tour of Temple. And again, those are available on undergrad admissions' website. So just keep an eye out for that.
One of the things that Colleen doesn't know about yet, I just heard about this afternoon, they are planning on in-person in the building, but you have to bring your own scuba tank. So if you have a scuba tank, you can come into our building.
He's joking, obviously.
That's
cool.
Today is these days are so crazy. You need a little bit of what I call, COVID's not funny at all, but I still will call it COVID humor. So
yes, that's a good point. Good point, Dr. Brookstein. So
take it for what it's worth.
Yes. So it looks like we haven't had any more questions come in. So I'm going to stop the screen share and stop the recording, but we're happy to stay on for a couple more minutes if anybody has any additional questions. So please don't hesitate to ask if you do. But I want to thank Dr. Brookstein, Dr. Jacobs, and PJ for giving their time tonight to talk to you all. This is I always enjoy these types of sessions because I always learn a lot about the majors and about what our students are up to, and it excites me as a staff member. So I want to again thank them all and encourage you all again we are offering campus tours on a limited basis. So please take a look at that. But until then, please continue to stay safe, wear a mask, stay 6 feet apart, and hopefully we'll be able to meet you all on campus and in person the old-fashioned way very, very soon. So thanks everyone for joining us tonight, and hopefully we'll see you in the future.
Bye-bye.